Hello guys, welcome to the channel. Today we will be learning about basics of maths which will be required for learning ML and let's get started. So today we will be learning about a real life problem through which we will learn the basics of maths. And so the things we will be learning is the introduction to a real life problem. Second thing, we'll be learning on processes of building ML algorithm. Then we will look into coordinate geometry, and then we'll look into half space intro. So let's get started. So let's say you are working in a company and they have a problem where they want to sort different types of fish, and there let's say they have some kind of machine where they push different kinds of fish here, and there's a scanner here which gives different attributes of the fish. So this is a scanner which returns attributes of the fish, and here based on the attribute it is sorted as type 1 or type 2. But here this is the problem we are trying to solve. So the company asks you to create a machine learning algorithm where it differentiates between fish based on the attribute, whether it is of type 1 and type 2. So this type of problem is called a classification problem. So what we are trying to solve is a classification problem. So in classification problem, we have a where we have a discrete option. We have only limited options or discrete options. That type of problem is called a classification problem. So let's start with let's assume we have different attributes such as weight. So the scanner returns us the weight, size, appearance, which can have color, shape, and maybe much more. So let's start with this. These are the attributes. So now, so after some time we get these data. So let's say the machine collects different data for different fishes, and we get data, let's say width, length, and weight. So this is the data we got from the machine, and someone has manually classified these by looking at this data. What is the type of the fish? So this is a hypothetical numbers. Okay. So this is the data. So what will be the first intuition to solve? How can you solve this problem? Mhm. Before going that there, let's define some terminologies. So all these columns from width to weight are called features or independent variables. And this type is called a target variable or dependent variable. This is called as data points, and the entire table is called as data set. So both these terminologies are clear. It's not much difficult. Now let's move on. How to solve the problem, given problem. Okay, so maybe a simple thing is we can do is write some conditions based on conditions if whether it falls as type 1 or type 2. So in so one way to do it is to add if else conditions, but there is one problem in this, that coming up with the conditions manually is very difficult, and if the data is very large, it's nearly impossible for us to uh, get the all the conditions right. Second way is to take help of coordinate geometry, and this is where the maths part coming in our machine. So let's uh, explore more on the second approach, how we will solve this classification problem. Now, given the data points, first thing we can do is draw a scatter plot. Okay. So first thing we can do is visualize our data. So let's say this is our x and y axis, and let's uh, draw plot some data. So here we have some data points. Let's plot another. Okay. So this is our, let's say, our scatter plot. Uh, Now, based on the plot, we can say that the blue ones are type 2. Let's say these are type 2, right? And green ones are type 1. So based on this, we can separate the points by a simple line. So let's say if I draw a line here, line here. So now we have separated the data points. Now, if a new data point comes in, let's say a new data point came up here or here, right? So we can classify, we can say that this is a type 2 fish, right? Like what we are trying to say is that at the new data points at lies on which side of the line. So if it lies on the let's say this is a positive side. So if it lies on the positive side, we say it is a type 2. If it lies on the negative side, it is a type 1 type of. And now there can be cases where the data points are not properly classified. Let's say there are some blue ones here. So these type of uh, points are called misclassification. So if there are some data points which are not properly classified by our separator, we call this as misclassification. Okay. So now next thing is next thing is want to explore how can we create this line. Okay, so because we have created one line, we can create one more line, something like this or like this, or many more, right? So which line is best fit? How can we uh, come to conclude that which line is the best fit? So we will look into that. Let's first explore what is the uh, equation of the line. So the line can be represented as mx plus c, if you remember in your lower classes, and this is what we call an ML model. So this is our simple ML model. Right? So let's understand this more in a simple example. Let's say you have given a data and y, and your value of x is n and value of y is 10. If your value is x is 2, value of y is 20. Right? So based on this data, what we can say? We can say x is 10 times, sorry, uh, y is 10 times of x. So this is our basic ML model. This is again a ML model. So if any new point comes, let's say if you want to predict what will be the value of y given the value x is 4, so you can say it will be 40, right? Now there can be case where there will be multiple classes. So let's say instead of 2 choices, there can be 3 or more. So that. So here let's explore multiple classes more here. So first thing is, let's say if we have more than 2 types of classes. In that case, we can draw 2 different lines to differentiate the class. But again, the problem lies here is how can we tell which line is best? Right? This is the real problem to solve. To solve this problem, we need to understand about the uh, line more, like mostly the equation of line. So what do you mean by M? What do you mean by C? Okay. So what is M? So what we can say that if you do a small change on the X, right, how much change will be there on the Y? Now, what does this mean? So let's say if we did a small change on the, we went from this point to this point on the X-axis. So how much uh, change will be there on the Y side? So if we went from this thing to this, the change on the Y will be from here to here. So that will be delta Y. So if we say that if we went from this point to this point and the change is the 1 unit, then the change on the delta Y is also 1 unit in case the equation line is y is equal to mx. Let's see another graph where we'll understand this more. So let's say here we have 1, at this point we have 2, and here we have 2, at this point we have 4, 6, 8, 3, and 4. So for this graph, if we move by 1 unit, y will be increased by 2 units. So if we move 1 unit on the x-axis, y will be increased by 2 units. So our y by x is equals to 2 by 1, and the equation is 2x. So this is our equation of line for this. So I hope you understand why the y by x comes up and what is the meaning behind it, right? And one more thing, uh, here this angle theta is y by x. So just adding that part here. So we say that m is delta y by delta x. Any change on delta x, what is the corresponding change on delta y? Now, in case, what will happen in case of parallel lines? What do you think will be the value of m? So let's say we have two different parallel, two lines. Okay, so this is one, this is another, and the equation of this line is x plus c1 and y is equals to m2 x plus. So what do you think will be the value of m1 and m2? Will it be different or same? So in this case, m1 will be equal to m2 because for both the lines, rate of change x and y will be the same, right? So that was about the basics of lines. What is C? C is the intercept. Y we call the slope, C is the intercept. So C is where it will cut the y-axis, the line where it will cut the y-axis. So in this case, let's take an example to understand that. Let's say if we have a line something like this. So this is our y-intercept. So this point will be our value of C. This is our, let's say, theta, angle meet by line from x-axis. Okay. So this is mostly the concept of. There are other general forms of line. Let's look at those. So we also have learned that line is b ax plus by plus c is equals to 0. Now here a and b are called as W1 and W2. In ML context, these are referred as weights, and this is what the computer learns. We look into these in more details in future, but for now, this is the basic idea behind it. And instead of x and y, we use x1 and x2, and they mean the same thing, that it has two dimensions. Right? C is represented as W0. So we are essentially changing the way it's represented. That is because we follow this formal representation in machine learning, and the terminology changes when we go to the machine learning side of representation. So if we conclude that, so we can say that the equation of line will look something like this when we start learning machine learning. Okay. What will happen? One more thing is that what will happen in case of perpendicular lines? This is I'm talking regarding the slopes. The product of slopes of two perpendicular lines equals to minus m1 cross m2 equals to minus 1. So this is something we can remember. So let's now go to half space. So these are things we are learning to solve our the problems where we want to describe what is the best line. So these are things we require. So that's why we are learning as a prerequisite before jumping back to that problem. So what is a half space? So let's say we have some data points, right? And this is separated by a separator. So this side is called as half space. Okay. So and this is also called as another half space. So let's say there a new point comes up somewhere, right? And we want to figure out where, like in which half space it will go. So that's our problem, right? We want to figure out if a data point comes up, where, what is the type of it, in which half space it will go. So let's understand this so that let's say you have a point x1 comma y1. An equation of our separator is y is equals to mx plus c. And on inserting the value of x1 and y1, we will have three different possibilities. So let's explore those possibilities. The first possibility, case 1, is that y1 is equals to mx1 plus c. That is the value, this value is equals to this value. So what does this means is that our point lies on the line itself. Lies on the line itself. Right? Case 2 is that y1 is more than mx plus c. So what does this mean? That y1 is greater than this part, next one. So which indicates that the point lies above the line. Okay. And case 3 will be y1 is less than mx plus 1. This indicates that point lies below the line. This was an example for two features. What will happen when there will be more than two features? In that case, we'll have three-dimensional space. And a separator will be a plane instead of a line. So what do I mean by that is, let's say if we have a three dimension, and here if you want to separate those points, so some points let's say here and some points let's say here, it will be impossible to separate it by a line. In that case, we'll have something called plane. Imagine that, right? We'll separate it by a plane. So these are called the hyperplanes. In 4D, it will be 4D plane, hyperplane. In ND, it will be ND hyperplane. The term hyperplane, because we cannot visualize beyond 3D. Okay. So we have come to the end of the lecture. One last thing is what will be the steps process of building an algorithm. So that's the process in building ML algorithm. So first thing we have is data collection. Right? Data visualization. That is what we did. We visualize our data in to a scatter plot, and the separator, which is a line. Chosen an appropriate geometrical structure to separate class. So we use line in case of more number of features. The separator will become a 3D plane or 4D or 5D or ND plane. Okay. Thus, it is easy to visualize a 2D plane or a line. We'll go with that for now. Choosing a loss vector which helps decide the best structure. And the last one is training and optimization. Okay, so in our case, we have done this part. Now we are almost done with this part. We are on this. We'll look into this in the next lecture, where we're looking like more into hyperplanes and how it works. So stay tuned and keep learning. Bye.